Hey mathematicians, here are your notes for functions day 1. So let's start off with a little bit of Algebra 1 review. What is the definition of a relation? We often use the definition, a set of ordered pairs. Remember that ordered pairs are made up of x comma y, and our x is always our domain. That's always our boundaries for our x coordinate. And our y is always going to be our range. That's always our boundaries for our y coordinate. Also recall, what are the three forms a relation can be represented by? The three that we most often use, although there are more, are the table, really basic, we're used to using that one. The graph, plotting points, we're all pretty familiar with that as well. And the one that's less familiar to most of us is mapping, but we'll see that a little bit too. A function specifically is a special type of relation. Defining a function is a relation, and this is where it's special, in which each domain or x coordinate has exactly one range or one y coordinate, meaning every single x value has a unique y. We do not see any repeating x's that go to different y's. So let's look at some examples here. We've got a table on the left, and then we've just got the set on the right. Notice that each x has its individual y. Each one is a unique relationship. Again, here we've got a -4 goes to 6, -3. There's no repeating x's that go to different y's. However, if we look a little lower here, we notice right away that we have a -2 that connects to a -7, as well as a -2 that connects to a +5. This is not a function. This -2 does not have exactly one range. It has two, meaning this does not fit our definition. You've also got 2, 0 and 2, 6, which also break it. Looking at the set, notice you've got a 0 that goes to 5, but you also have a 0 that goes to 8. Since it does not have a unique output or a unique range, it does not fit our definition of a function. Let's look at a map of this set and see another reason. Some of you are visual learners. That's awesome. And I think sometimes a map really helps to see this. So 5, 4, 8. All I've done is I've put the domains in the left box and I've put the ranges in the right box. And then when I match them up, notice this has one unique output. Great. However, 0 goes to both 5 and to 8. That is not a unique output. Anytime we see that setup, we know it's not unique and therefore is not a function. All right, let's jump to the back. Really important note here is that y coordinates, so the range, can repeat as long as they repeat with different x coordinates. So we don't like it when x's don't have unique y's, but we're okay if we have y's that we can have a -2 and a -2 as long as they have different x's here. So why is that? Well, one way to look at this is by using the vertical line test. So the quickest way to determine whether or not a graph is considered to be a function is to use this test. So what is it and why does it work? Well, if any vertical line, give me a minute, Trey, if any vertical line crosses a graph more than once, then the relation is not a function. Is not a function. So if we look at some examples below, this one here on the left, I like to use my pen as my vertical line. Remember, vertical, up and down, horizontal, side to side. So if I vertically follow this over, I notice I'm okay until we get right about here. Whatever this X value is, I hit this line not once, not twice, but 3 separate times. Now, if I were to give you the coordinates for those points, I would have, it looks like -1, -1. I'd have -1, 3-ish. I know these aren't quite right, but -1, 5, approximately. Notice I've got 3 of the same domain with 3 different outputs. This breaks our vertical line test, and it also doesn't fit our relation of a function. So that's why this vertical line test is helpful. Notice, if I go horizontally, I can have the same y value. I can have, if I go here, what is it, -4, 1, -2, 1, -1/3, 1. It still passes the vertical line test, so our y values can repeat, but our x values cannot. 2 easy ones right here. I follow that across with my pen. It doesn't hit at any point more than once, so that's a function. Same thing here. I'm going to follow that line with my pen. It does not hit at any point more than once, so that is a function. This leftmost graph is the only one that is not a function. So, vertical line test, very helpful. If you have any questions, don't hesitate to let me know.